Welcome to the lecture series on object oriented analysis and design. One of the highlights of switching over to object oriented analysis and design is the fact that it holds the promise of creating pieces of software which can be nicely packaged, made into components, and we do not have to redo that exercise again if only we can find out which are the most commonly occurring requirements in code. We can convert them into packages, we can convert them into components. It is enough if you know how to use those components, you need not know what exactly is happening in the component, we need not know what is exactly happening in the code that has been already made. It can be a black box, it can be a component. So, these are certain ideas which were very promising in object oriented analysis and design. It is not that other paradigms were not talking about it, it is a fact that we understand that other paradigms also spoke about it, but object oriented analysis and design as a paradigm holds the maximum promise to make this happen. What is the advantage of doing this? We know that there are lot of applications across many domains, but each time when we talk about writing up an application, we find that there are common things which many people would want to do. For example, let us say we want to write a word processor. Definitely all of us would agree that whoever develops this word processor, whoever is writing up this word processor will have to have provisions for opening a file, closing a file, opening an existing file, creating a new file, some edit commands. There are a few things that at least 7 to 10% of any popular word processing package are common. We can write our own word processing package. As a matter of fact, a group of students so many years back, maybe early 90s, it was a big challenge for us to see how to make the development time of creating a word processor become minimum. So, what we did was we started looking at the graphical user interfaces, they are all packaged, we called it GUI for word processing, it is called a word processing library. So, all word processors require a few things which are common, they are already pre-done, prefabricated by us in the sense of fabrication, the software is done very well, the testing is done very well, that component works. All these components were nicely put together into what is called one package, a packaged library. You can simply call these packages out into the code. In a few lines you would have developed your word processor, the word processor becomes to become active. You do not have to purchase any word processor, because all of us knew that about 10% of word processing is common. Most of the users are contented using 7% of these. So, for the regular typical word processing exercises, we do not need a very sophisticated word processor. All the common things will simply be put together and made into a library. It has a very good GUI, you can just link it. So, if you are not writing a word processor and if you are developing what we saw yesterday like an integrated development environment where the code is still written as text, it has a graphical interface. We have seen some wonderful packages on Smalltalk. As you write the code, you will see the graph. As you touch upon the graph, you will go to the corresponding code. So, such nice ideas where the code is essentially text will be possible to do in a word processor. It is helpful. We may not be doing a commercial word processor like what we are talking about, a Microsoft Word or a WordStar or a WordPerfect or whatever it is. We are not really doing a commercial word processor, but word processor enough to type in your code, edit your code, check your code, submit to a compiler. So, there are many applications. Those 10% of the features are very handy, very helpful. So, this was a simple project which we did. A few of 2 or 3 undergrad students were there and we did that project. It was very nicely received because it makes writing up that word processing component very simple. Well, it is too simple an exercise today. At that point in time, there was a serious resource constraint. The context has changed. We did not have that much memory to play around. Writing up GUIs was a big exercise. we could not simply program the windows. It was not easy to program windows. Those were the days when programming windows was a very intensive exercise. We have to do a lot of referencing. Things have changed now. Plenty of simplification happened in all these things because a lot of people are developing apps. So today we can talk about converting many things into the apps. Plenty of simplification has happened in terms of developing some components. It is true that what was promised across many paradigms, many programming paradigms all along right from the day one as software reuse has found maximum capability, maximum possibility in what is called object oriented analysis and design, and today it is doable. So many things have changed. We know how to work with GUIs. It's very easy to construct any application with GUIs. It's possible. We have talked about visual programming paradigm. We talked about mixed programming paradigms. However, please understand that we do acknowledge that it has become faster, but did we create that many components? That's the question. Developing a component is faster, making reuse of some well known components is faster. It's true with every popular package. I have come across a wonderful software developer, a very good software engineer who has looked at the accounting packages. They were very popular accounting packages, but then they were very expensive. So what they did was they broke it down into small components. Every programming paradigm has been talking about software reuse as a very good idea. Why should we do things over and over again? In other words, why should anyone reinvent the wheel? It is true that several common activities happen in very many applications. Why are we reinventing the wheel? Simple question. Look at many packages you use often, at least you will automatically understand that given any application 7 to 10% are some things which are found everywhere else. Common things, common activities happen. So what we found was it is good that object oriented held the maximum promise. It is also good that it has enabled the simplification of making such things happen, but we didn't have too many stories in that area, too many successes. Look at the hardware component, plethora of ICs. It is true that in the beginning nobody gave it for the integrated chips. We thought a few chips may be made, but today you see the hardware market is so well matured that there are so many components. A big catalog comes, a very big catalog comes. They are all off the shelf. They can simply pick it from the shelf, purchase, pay it, and then you get the component. It has its own flip side. For example, very early in my BE I did one internship and we had to create one RC filter. So you can create, in theory there are only two variables, resistor value, capacitor value. You can vary the resistor and make the capacitor happen, you can vary the capacitor, make the resistor happen. It's a very simple problem, very simple problem we were talking about. Luck was like that in my case, that I ended up with an R and C combination where the capacitance is simply not available in the market. The maturity of the hardware market is such that it dictates a few things in the reverse, whereas software is very flexible. I can tell that no, don't worry about it. If it is a simulated capacitor, simulated resistor, I can build whatever I want. I can choose my own values as long as the filter equation is satisfied. How does it matter? There are only two variables. I can simply change R and C and I will get the same RC filter. The equation is clear, the design rules are very clear. And here we are running a hazard in software that we don't have that many design rules. The challenge in software is the change. And yesterday I was talking about, in the earlier lecture on Smalltalk, said that very first time in 1980 it was demonstrating that change is something which is so easy. Everything is an object. Change is something which is a common fact. This was in 80. And the ideas that Smalltalk has provided are all akin to what we are talking about in what is called reuse. You can simply put them, please play around with the component code and you will get it. So what we did is a very wonderful idea called software reuse, but then we could not really show that many components. Today you look at the electronics industry, it's a big catalog. Huge brands always have a very big catalog. You don't have to search far Whatever you want to do, it will be there. Even today we keep telling the same thing, whatever you want to do in software, you can do in hardware and vice versa. Hardware is fast. If many components are made, many people have a demand for that component, the component cost will come down. Software is very slow. Making it one time is very expensive, but after that we do not know how to charge the next component outside of the medium. What else is chargeable for the second copy? Difficult questions. We are not answering all questions, but what is the fact that we are talking about is hardware is inflexible. Once it is cast, it is cast. As long as there is a market for that component, it sells. Software is very flexible. It promises that it is extendable, it can change. Today it is only this much, tomorrow it will become more. So, we have seen the pluses of software, we have seen the intellectually stimulating challenges of software, and the promise that next day we will move to a better complexity, not a linear complexity, 100 times complexity. With the skill set that we have built in today, next step will be 100 times complexity. That's where the software industry has been thriving on. That's the challenge which we face. So, today if we have gone here, so it's a matter of surprise, it's a matter of intrigue that software reuse did not really happen in that much of numbers. So, we started talking about what is called black box. It does not matter to me, an idea of black box, somebody developed the code, this is the claim, as long as the basic interface testing is done, I should be able to use it. Like a logic analyzer, I will build a component testing and then go ahead and use it. Now, the fact is again true that most applications have common things, but we are not able to produce that much of software reuse, which has been in the pipeline for many, because it is almost a commonsensical argument that let us not reinvent the wheel. There is no point in reinventing, we need to progress. So, why is it like that? What is the software reuse? Why is it so intriguing? It was such an attractive idea, but then most paradigms promised, but only object oriented held maximum promise. While all these things are true, we still want to do so much of exercise on what is the commonality across applications, across domains, across multi stakeholders. We are not able to show that many components to make it a catalog. There was a point in time when people were talking about software component factory, object factory, just like an assembly line produces, it produces so many off the shelf. Even today we talk about off the shelf in software, but the commercial off the shelf, that is whatever has been packaged, it is it will do like this. You talk about Word, it is a cards, commercial off the shelf package component, you can pay some money, purchase it, nothing can be done with it. It is like that, you use it or throw it, that is how it is. So, from the project mode to product mode, and then we started talking about open source, let there be some open source components. Today it is good, we have some open source code segments that are available, huge code bases. Time is ripe again for us to talk about software reuse, because that is what they are doing. Millions of code bases are there. Earlier lectures, I did not want to repeat the slide again, there is a big slide that tells that lot of code bases are there. Yesterday in the lecture which I did on Smalltalk, the TOBE is doing 1056 million codes every day, lines of code every day, huge codes. So, the point is there is a need to understand software reuse more closely, even though the promise that was held did not really happen with that much of quantification, that much of quantity. The idea is great, time is ripe that we are going back again to understand why, what is it difficult in software reuse, advantages of reuse, what is reusable, types of software reuse, stages of reuse development, reusability measurement, the problem in software reuse, impediments. This is the outline of this set of topics, the set of lectures. What is software reuse? Software reuse is the process of implementing or updating software systems using existing software assets. We are all very clear that across the organizations, gradually over a span of time, several pieces of software have already gotten into. We are only talking about commonly well known, well highlighted pieces of software like email reader. Today in the open source world, many things can happen. I did mention in one of my earlier lectures, there is a Microsoft Code Fun contest where plenty of pieces of code are given, and over a weekend, 48 hours exercise, they should use, teams will use their imagination to pick a set of code segments, put them together to make a working application. Whichever is the best application that they make according to some jury, they will be getting the award. And we are talking about millions of code bases, we are talking about code bases that are ranking programming languages. 3 examples happened in this lecture series, giving us that impetus to understand that it is a fact today that we do not want to redo from the scratch anything. Where possible we want to reuse, but why did not reuse happen with that much of clarity and success so far, even though the idea is appearing commonsensical? That is the intriguing question. That is what we are trying to do. The definition is like this: the systematic development of reusable components, the systematic reuse of these components as building blocks to create new systems. An idea which is there in all the examples that I have taken. I made a deliberate choice of the Code Fun contest, which is like that. There are so many such contests. We can talk about many contests. You can see the code segments on its own. The code segment is not signaling many things outside of the bare minimal functionality. You put those functionalities together, put some more lines of code, you should be able to develop an application in 48 hours. Alarming is we are developing mobile applications. I have seen a school student develop a commercial grade mobile application. It was hosted on the stores, mobile stores have accepted, it passed the quality constraints to be put in the store, a price tag was also given. I would not know what has happened after that, but then it is true, it is a fact of life. So, it is imagination. Lot of code segments today are floating, they are all there. You will have to use the ingenuity, imagination, and then build it across. Very rarely in this method of open source, new, totally brand new applications are happening. That's something which we need to think of. It is more like replicating certain things which you have already seen. However, we think that in the commercial off the shelf world, there is a high potential for something which is brand new, non-existing happen. That is a subtle difference we have, but then let us focus on software reuse for the purpose of teaching, learning in an academic institution which thrives on what are the existing code segments. Maybe a project has been developed earlier. This was another idea which is very live and active. Whatever has been happening as projects in the earlier years, earlier semesters, the code bases are deposited on a common server, and the next batch that is doing projects may hunt through the code bases, see how it can improve, how the code base can be built further, examine the existing code bases, because that itself is a learning in programming. We should know how to read, understand the code written by others. Even though it is a very well known statement that if you have to change more than 10% of the code written by somebody else, you better start from the scratch. Software reuse, particularly using OOAD paradigm, is promising that no, don't think of all those things. This is a definitive reality. You can look at the existing code bases, you can see how much of change has to happen, that becomes white box. If you know the internals of that code segment, it becomes white box. If it is not known, the internals are not necessary, it becomes black box. Black box is more oriented towards what we called the components, IC chip, only a number is there. The IC chip number is there. A well known timing circuit, IC 555, it is like that. So, what we understand is that wherever you go, wherever the timing is necessary, the timing diagram is necessary, it is like that. We are very good on asynchronous. To synchronize, you need a clock tick, and that clock tick, one of the most well known components is IC 555. The hardware market has definitely matured to an extent where it is able to show a catalog. Whether the difference is a significant difference or not, similar looking functionality, but different brands based on the cost, we can talk about that market which has matured so much. Lot of IC brand names come, it is a big catalog, resistor components and everything. There we see tangible components. Here we are not able to see the tangible components, they are more abstract. So, it becomes that bit more difficult even to systematize the development of reusable components. In the hardware market, yes, it is very systematic, building blocks of creating new systems. Increase in software productivity, it is a paradox, productivity is a paradox. If somebody claims that they are proficient in ANSI, the expectation is that they should develop 60 lines of code in 8-hour working day. Roughly every hour they should deliver 7 lines of working code, and every 7 lines of code which is accepted will have one defect on an average. This is the meaning of productivity. It is a paradox. What is the meaning of 7 accepted codes with 7 lines of accepted code with one defect? When is the defect going to hit? Please look at the earlier lectures. We have addressed all this. There was a verification and validation. We need to understand this carefully. What exactly is software productivity? We have been postulating that software is a very creative endeavor. Depending on the problem, we will have to find. It is not like one brick takes 1 hour. In 8 hours, how many bricks can you produce? 8 bricks by one person. 2 persons, you should be able to produce 16. It is not that linear at all. The idea of work, the time and effort, which is seen in many engineering disciplines where the tangibleness is very high, is simply not translatable into software. Time and effort is a different exercise in software, and therefore, IT productivity is a paradox. We strongly believe therefore, that whether the development of code from the scratch is happening or not, even if 10% of the components work, the productivity will increase. Why should I believe that the component which is developed elsewhere, not by us, is going to happen correctly? Well, that is up to you, that is a business constraint, that is your business environment. Therefore, we are not really moving out of the business context. It is the business context that drives, it is the business context that takes us to the operations. It is just that how to fit into the business context. Therefore, we go back once again and tell that it is use case driven, it is requirements driven. Because of those wonderful features of object oriented, the propensity of reuse is very high. It shortens software development time, it improves software system interoperability because they are common components. You see how nice it is. For example, IBM had this wonderful idea in the beginning saying that common user access, CUA, it came from IBM. IBM was known for everything under the sun related to computing. You just use IBM, most probably it will be there, it will be done by them. That is a brand which we are talking about. It was there like that for several years. One of the first things that moved out of that method or that kind of a stranglehold is the printer, Centronics printer, where they said we will write device drivers. To cut the long story short, the mainframe world has given way to mini computers, then to personal computers. Today we are not talking about a one stop shop like what we were talking in the beginning of computing. It is not really a one stop shop. So, what we have done therefore is the fact that we need to understand that common user access was thought of by IBM, saying that whatever piece of software they develop, the interface is going to be the same, it looks the same. Did not happen much from within the IBM, but then one of those huge successes using this idea has been the Borland. Turbo products, all turbo chain of products, Turbo C, Turbo Prolog, Turbo C++, Turbo whatever you want to talk, has the same user interface. Once you are acquainted with one turbo product, all turbo products are automatically known to you on how to use them. There is no need for studying them again, familiarity is there. So, this was a very good point which we used to score each time when we were applying when we are making a purchase recommendation of a turbo product version 1, version 2. This question used to come, why should it be branded? The branding has a flip side because we do not want to use the term ANSI anymore, it is Turbo C. Everybody talks about only Turbo C. What is the standard C? ANSI. Everything has a flip side. We will have to understand that why this brand name has come, Turbo. Well, we write the same justification over and over again, saying that it breeds familiarity, training time will be less, therefore, the students and the faculty will focus more on programming, editing their code, working their code. That is the core, that's the way we want to teach a laboratory. The laboratory should focus on the programming, the editing and all, not much on studying the user interface and having the problems. It operates similarly. So, we had a series of turbo products on the stock. Each time we write that paragraph remains the same, it's something like, once well written paragraph, it carries forward. Turbo C, Turbo Pascal, Turbo Prolog, Turbo C++ at one point in time. It was like that. They were different and they used to give very good discounts for the university. Improve software system interoperability, that is the key. We should know how to move very quickly from one language to other language, and we should not be bothered by the interface. So, that is what we are talking about. In the field of ICs, it was so crystal clear to us, VCC is going to be here, GND ground is going to be here. It is a dual inline package, you should know where the dot is, automatically you will see the numbering of the pin. That is what we mean by maturity. All people appreciated that. If we follow that, the market will increase. It is a dual inline package, both sides you will have the pins, all gold plated pins will be there. There is a dot on one side, and you look at the dot, face the dot, the power supply will be at one place, the ground will be at one place, and they will have a pin diagram. The simple one fact sheet will come. This IC's pin diagram is like that. As long as the logic analyzer says this chip is usable, that pin diagram goes operational. We need not know what is happening in that simple IC chip, which is all black, and maybe nothing is visible on that. We go by whatever is told, this is IC number so and so. That is what we mean by maturity in the development side. Everything has its own flip side, but what it is assuring in one single term is interoperability. That is the reason why we were able to build hardware systems at neck breaking speed. It is so easy, it is so easy to do that. So, we can fabricate, fabrication units have become very popular. You give one of my students who came from the US was mentioning that a part of his course on compiler writing was making a chip. They had to prove certain things. So, he simply gave the chip design to his fabrication unit and flew to India. By the time he returns, the chip will be ready. Just a few weeks, the fabrication unit will make the chip. So, what is the point that we are making? We kept on harping on the fact that hardware is mature, hardware assures interoperability at a neck breaking speed, but it is inflexible. We are not so clear in tasking, we are not so clear in time and effort, therefore, software will always score. It remains a true challenge to make the software systems interoperable. Reuse is still the core idea. Object oriented promises the maximum possibility of software reuse, but still it is a long way ahead. Thank you.